This is a worked example on how to find the value of a trig function at an angle that isn't at one of the major points on the unit circle. And the way we'll be doing this in this specific video is using the sum and difference identities. So the main idea behind this is you have some angle theta, right? That's this angle right here. And if you look at a unit circle, 13 pi over 12 is not one that is included. It is an angle which is coterminal, like it's greater than 2 pi, but it's coterminal to pi over 12, which still is not on the unit circle, so we need to work a little harder to figure out the value of it. So what we're going to do is we're going to break up this angle theta into two other angles, alpha and beta, and I'm going to use red and green because my roommates are decorating for Christmas and, be in the Christmas spirit. So we'll break it up into two different angles, alpha and beta, and then we'll take advantage of a sum or difference formula to actually put together the value of this function. So first thing we'll look at is how do we turn 13 pi over 12 into a sum so that the angles alpha and beta are on the unit circle? Well, you might need to try a few different combos. What I like to think of immediately is you are going to want to split it up in a way that it kind of reduces to a nice looking value because, well, the unit circle includes like nice looking values. And the numbers that pop into my head is, well, I want to think what can be reduced alongside 12, right? And if you separate this 13 into 10 and 3, and I've broken my color code, but split it up into 10 and 3, what you'll notice is these angles actually reduce. So, and by reduce, I mean the fractions, right? So 10 and 12 are both divisible by 2. This becomes 5 pi over 6. And the beta angle, 3 pi over 12, that reduces to pi over 4. And so in doing this, we've now found two angles that are on the unit circle, because if I look at a unit circle, I have 5 pi over 6, I have pi over 4, and I can now work with this. So let me erase some of my scratch work here, but what we now have is we have cosine of these two angles, and this is what we're going to be using to figure out the value of cosine 13 pi over 12. And then we're also, this is an addition, and we're working within cosine, so the formula I want to use is cosine of alpha plus beta is equal to cosine alpha times cosine beta. That is minus, right? Yeah, minus sine alpha. And I'm running out of room here. Sine. My headset just shut off. Yeah, anyway, I was just reading the rest of the formula. Okay, now that we have our formula written out, we can go ahead and sort of split this apart. So we are going to get, and I will try and save room here, we're going to get cosine of alpha, so that is 5 pi over 6, times cosine of beta, that is pi over 4, and we are subtracting sine of alpha, that is 5 pi over 6, times sine of beta, which is pi over 4. Okay, now I can look at a unit circle, and I have a unit circle up next to me, and we can use this to determine what the values of all four of these components are going to be, and then we're going to, kind of simplify that out. So, what are the values we get? All right, so cosine of 5 pi over 6, that is going to be an x value, and that will give us negative root 3 over 2. And then that is being multiplied by cosine of pi over 4. Again, that's an x value, and that is root 2 over 2. Subtracting, and then in new parentheses, we have sine of 5 pi over 6. That's a y value, so it's going to be 1/2. And then we have sine of pi over 4, and that is a y value, and that's going to be root 2 over 2. Okay. Now, technically, this is a final answer, but we obviously want to simplify this so it looks a little bit nicer. So I'll try and make a nice bit of room so I can simplify this here. Let's first simplify this side of the equation. So we are going to get, we can multiply across the numerators, you get root 2. Multiply across the denominators, you get 4. And then that can stay in parentheses with a minus sign. Over here, the 3 and the 2 can multiply to be root 6, and the 2's multiply to be 4, like that. Let's see what we can do now. Is there a way I can make this look nice? Okay, so let's sort of attach the minus sign to the 6 explicitly, and let's attach, we have the minus sign to the 2, and then this will become minus root 6 minus root 2 over 4. And then what I'm going to do is let's factor out a minus sign so that it's explicitly on the outside of the fraction bar, and that'll get us root 6 plus root 2. And I believe, and I want to check myself, that should be the final answer. Yeah, that is the final answer. And so if I move this back up with the rest of my work, this is the final answer. I don't have a great place to put it, but it's going all over the place, but this is the final answer for cosine of 13 pi over 12. So that's a way that you would find a value of a trig function that isn't necessarily on the unit circle, and we took advantage of trig identities to do that.